let's talk about writing proofs. So this is the proof process, and the whole idea is if you can prove that something is true, it is a theorem, and then you get to use it forever, right? Like I was talking about it before with these books with Euclid. The people that kept making math for the centuries and millennia after this guy, they used the stuff in his book because he already proved it. They didn't need to do it again. They already knew it was true because they checked his logic and his reasoning, and he had sound deductive arguments, so they were all valid, and then they were just able to continue on. All right, so that's the idea. Once you prove something is true, it's just true forever, as long as you meet the conditions. Right? That's like the law of detachment. You have to meet the hypothesis to get the conclusion. So, what does this kind of look like? Step one, we're going to list the given information. That always comes from the problem. And if possible, you want to draw a diagram to go with it to illustrate what's happening. That does two things. One, that helps you kind of understand the scenario in your head because you can start to visualize it, but it also gives you clues on how you're going to use other random bits of facts and postulates and things out in the universe of mathematics when you actually start making some deductive arguments. Then we're going to state the theorem or conjecture that we want to prove. So these first two steps, those things are from the problem. They're going to tell you straight out in the problem what you're given and what they want you to prove. All right. Now, step three, we're going to create a deductive argument. Remember, that's things like law of detachment. Oops, spelling detachment wrong. Law of syllogism. And it's also all the facts, rules, postulates, other theorems, all the things that we've shown so far. That's when we use all of that stuff there. And so you're going to want to go through all of these things that we know and we learn, and that's what step three is going to be all about. And step four, where we justify each statement, that's where things like logic and law of syllogism all come into play. And then once you're all done with that, you state what you have proven, and that is basically restate what they wanted from the problem. All right? And hopefully it's true that you've been able to get there using these laws of logic and all these facts and rules. So if you've had valid arguments the whole way, and you reach the conclusion that you want, then you've proven it to be true. The method we're going to start out with for proving things is something called a paragraph proof, right? Now, math has this problem where we name things and they make sense to us, but when you're outside of math and you take a look at how we named it, you're like, well, then why should I believe you? Because one of the names we call these things is an informal proof. Now, the reason why we call it informal is this sound like the paragraph proof is written on a way in the way that you would just speak it to someone else. It's not very formulaic. It's not super structured. You're just saying it in words written on the page. That's why we call it informal. If your logic is sound, the argument is still valid. So even though they call it an informal proof, it's still a real proof. This guy Euclid, he did that. He didn't have algebra back when he was doing this. Algebra wasn't invented when he did all of this. He did all of this with just drawings, circles, and straight lines, and given stuff numbers. So, but I mean, all those books I just were showing you, these are all done with informal proofs or paragraph proofs with diagrams. All right. So they're still good. Example 3, write a paragraph proof. So let's remember our steps. The first step is to write down what we're given. So we're given that M is the midpoint of XY, a segment. Write a paragraph proof, wow, good spelling there, Mr. Willig, to show that XM is congruent to MY. So, when I go to write this down, I'm literally going to write down, given M is the midpoint of XY, I will prove, what do they want me to prove? That XM segment is congruent to MY segment. So I take what they're giving me, and then I tell them what I'm going to prove. Now I have to go and do it. Think of it like an essay. The introduction paragraph tells you what the whole rest of the paragraph is going to be about, right? Or what the rest of the essay is going to be about. Same thing here. This first sentence is, here's what I know, here's what I'm going to prove. Then you put in the work to do it, and then at the end it said, see, I proved it. That's how this works. Let's draw pictures that go along with this. So we have a segment XY. M is the midpoint of that segment. Okay? Well, what do we know about the midpoint of a segment? The midpoint of a segment says that it cuts the line in half. The definition of a midpoint is that it cuts a segment into two congruent parts. All right, so it cuts it into two congruent parts. That's how we mark that with symbols. That's the part in red right there. Now the thing is, what are those two parts? Well, those two parts are the segment. These parts are segments XM and MY. Therefore, so let me write that better. My H looks off. Therefore, does therefore have an E at the end? You think there should be something to know with how many times I've written therefore in all the proofs I've ever done. Yes, it does. See, I knew it. Therefore, that's how you signify you've reached the end of your argument. All right? Therefore, XM is congruent to MY. I was given the information that M is the midpoint. I looked up the definition of midpoint. It said it cut into two congruent parts. I identified what those two congruent parts were. I said, therefore, they are congruent to each other. Now, it's customary at the end of a proof, whether it's a paragraph proof or two-column proof or any other kind of proof you do, to use some sort of symbol to let the reader know you have reached the end. Some very common ones. You can write QED, which is it's a phrase in Latin that basically says, I can't remember how it is, like quantus errorum demonstratum. It basically says, shown without error. You could also do an empty box at the end. I like that one because then the teacher could check it off and say, yep, you've got it right at the end of it. Another very common one that you can see in proofs is 3 dots. Let me not do those in red. So that's kind of funny. So you can do three dots. That is also a symbol that you can write at the end to signify it's done. And this is your flavor. You know, professionally, when I was taking math in college, it was usually the three dots or the QED. Some people like the square box so they can put a check at the end to say they like the proof. Though in college, my proofs were so long, like sometimes pages long, that there would be all kinds of marks the whole way through it, right? To show that I was making sense along the way. But if it's your style, you can draw a little heart there at the end of it, or you could draw like an eyeball. Ooh, can I draw an eyeball? Wait. And no, yeah, there's an eyeball with some crazy eyelash going on, right? So you can draw whatever symbol you want at the end, as long as it's appropriate for school, right? To demonstrate that you have finished it. But the basic ones are a QED, the square, or the three dots, whichever one you would like to use. Oh, and by the way, we just proved the midpoint theorem. So every theorem that you come across in the book is something that you can prove. Or I can definitely prove it, right? So the idea is anytime we have a theorem, it is something that is provable with the techniques and knowledge that you have learned so far in the course, which is kind of powerful.